Yo, what's up YouTube? So, second video, I'm going to show you how to make dovetail boxes today, and I found a really good way to do it. You might have a better way to do it. Check out my way to do it. If you have tips for me, leave it in the comments below. Once again, I'm going to ramble. I'm going to ramble for most of this video. If you don't want to listen to me ramble, I'll put numbers, time numbers in the description, so you can skip to where I actually do work, and otherwise just enjoy me rambling. If you don't want to listen to me rambling, then jump ahead in the video. Okay, so I'm going to show you something today. This guy here, this is a finished box that I did, and dovetail box. You can see it has all the details in there. I could save something like this and send it to a client, and they can see exactly what we're gonna make for them. I could put different wood textures in it. I could put dimensions in it. The other cool thing about it is I made all of my parts accurate to my actual jig that I use to make dovetails, and that's cool because I can take these parts and I can print them, and I know exactly what dimensions I have to make everything, and it's really useful. The other reason that it's useful is, say I wasn't making a box, say I was making a drawer box or something like that, then I would know exactly what sizes of drawer boxes I can fit in each cabinet, and it's a really easy way to skip this and not have to do this again in the future, because every time you draw a complex model like this, it's going to take you forever when you first get started. So what I like to do is make design resources. So when I say design resources, I say stuff like dovetails. I don't want to go and redraw the dovetails every time. And what I did is definitely overkill. You definitely don't have to do everything that I did. But I like it because it saves me time, and everything that saves me time and increases my workflow makes me more money. So let me show you quickly what I did. So let me pull this up for you here. This is definitely overkill, but I use a lay dovetail jig. I use the RTJ 400 when I make dovetails, and it's a router table dovetail jig. One sec. Drink some coffee. It's a router table dovetail jig. The cool thing about it is it runs on the router table, so it's really easy. I don't have to hand cut it every time. One thing about it that it's a little weird is that they have these odd sizes. Let me just zoom in here to measure the full tails. So when you count the tails, this is one tail. Or sorry, that's a half of a pin. But let me zoom in here. You can see what I mean. These are tails. That's a tail of a dovetail. So they count it by full tails. The weird thing about the RTJ 400 is that it goes in 1 9/16 inch increments. So 1 9/16 inch is one full tail. 2 full tails is 1 1/8 inch. 3 full tails, so on. So I'm not going to go through the whole list, because obviously you can go up to 10 full tails on this thing, and that's 15 5/8. That's plenty big for most applications, and that's going to be the actual height of the drawer. So that's a tall drawer, 15 5/8, or a tall box or whatnot. I probably wouldn't do anything more than that, and you can actually probably do this. You could do 2 panels and laminate it together. But so this is my design resources. So I save all my files, resources, dovetails. That way I can go through my different resources, other things I might have, like textures and whatnot, or live edge boards. I don't want to draw a live edge board every time. So here you are. There's your lay RTJ 400 exact sizes. Now, you might not use a lay RTJ 400, so my sizes, they're not going to be the most useful thing to you, but I'll show you how I did this layout, and you could do a layout like this. Like, say you're not using the lay RTJ 400 and you don't need to do 9 3/8, 10 5 15 16ths. Maybe you just want to do 2 inches, 3 inches, 4 inches, 6 inches, 7.5 inches, whatever. I'll show you how I did this quickly, and we'll go from there. But I'll show you why it's important. The reason why I have this resource is when I go to a box like this box. Let me just pull this up quickly here. I don't go and draw this every single time. I pull the shape from Sketchup, and I just add my textures. it's way easier. This is the same dovetail as on the list. The other thing is if I'm going to make a box, I'll make the box and I'll cut it just like I would make the box on the actual table saw. And I can see all these parts. I can see, how big all these parts are. It's super easy. So start from the beginning. We'll do a quick rundown of how we actually do this, and then we'll go from there. So if you are using a dovetail jig, you can usually find it on the internet. Go to your browser, search whatever manual. So dovetail, jig, XYZ. I don't know which one you're using is called. I use the Lay RTJ 400 manual. So you just Google that. Everything will be on the internet. It's a great thing about the internet is everything's on there and it's ready for you. So pull this up. For us, it has all this stuff laid out here because Lay is amazing like that. So you got half pitch here. I think I did mine for full pitch through dovetails. So just check that out. And you could do whatever here. This isn't really important. This is just me rambling to give you a sense. So, they have all the information you'll need, and we're essentially making something like this. We want to make this tailboard and that pin board. But the cool thing, let me just get to where it has it on here. Their website's pretty slow. This will be one of those things where in the description I just say skip ahead to that section. So here we are. Let me pull this up a little bigger if I can for you. So they're the exact sizes for mine, and as you can see, it goes up 1 9/16 every size. Which it might not be important for you. You might, as I said, just be doing even increment sizes because that's what you make. The important thing is we want to make, this board. This isn't actually capturing it. We want to make this board, where we have every version of our full tails, and then, if you're going to make more and more boxes and they're all kind of a standard, you want to have these standards already done. So, like on my jig, I have every box I'm ever going to make in these parts already. So when I look at this, say I want to make a box with this size, I have my pins board, or 1/2 of the length of it, and I have my tails board. So I'll show you why that's important. So let's pull up a working file here. And, it doesn't really matter what size box you're going to do. These guys, 4 11/16, that's probably fine for a drawer or a box. So let's pull that up. We'll go to our working file here. We're going to take that. So how did I make these? I have this little angle here. That's my router bit that I use. But say you're hand cutting it, maybe you're hand cutting this shape. Well, what is this shape? Essentially, what this shape is the size of half of your pin and the depth that you're going to cut. So I actually usually make 1/2 inch or 3/4 inch thick boards for drawers, or 5/8 of an inch, depends on the project. So that's what you're going to want, is figure out whatever material is that you're going to do. Say you're doing 3/4. What you want to do is make this shape. So, a common dovetail joint is 8 degrees. You might have it in a ratio, 1:6 or something like that, which is totally fine. Let's say you're doing something like me, where you're doing just an 8-degree joint. I'll show you how I did that quickly. So specifically for my purpose, we'll delete this just because we don't need this for a second. The lay dovetail jig uses router bits to do the cut. You can look up the different lay router bits that you might use in your jig. So let's look that up. Just give it a second. The lay site's really slow. The cool thing about it is, say you have this these sizes here. I know I'm going to use the 8500 to do the majority of my dovetails because it's a big bit. It's a 1/2 inch wide bit, and it makes a nice looking pin. Lay's site has all of this information on it, and all you really want to do is see this image here. It shows you sorry, I zoomed in too much. It shows you the depth of the cut that it can do and the overall diameter of the bit, and that's what we're going to use. Oh, that and the angle of this bit. So scroll down here to the 8500. So 8500 here. You have B, which is your cutting depth range, they call it, 13/16. A, your overall diameter, 1/2 inch. And it's pretty small there, but F is your angle, 8 degrees. And that's 8 degrees from the side to the cutting tip. So that's your 8 degrees, not from any other point. And you might screw that up the first time you measure it, but I'll show you why that's important. So here's our dovetail jig. So let me just make this rectangle. It's easier to make it this way. We have our 13/16, which is our actual ability to cut on the lay router, and we have our 1/2 inch cutter head, which is the actual width of this cutter head on the lay jig. So, and if you go into here, there's our 8 degrees. You can see at the angle finder at the top. So you might not be using that cutter, but say you're using another one. Say you're using something that's 10 degrees, something that maybe you have 3/4 inch, let's say. It's 3/4 inch length, and it's 1/2 inch cutter head. So there's yours. Just imagining that's what yours is. Take your actual router bit, measure it, or look online, and you'll see that. You can take the protractor tool in Sketchup, go to one of the corners, go from one of the lines, and put whatever angle it is that yours is. So say yours is 10 degrees. You can pull up your line tool. I just press L, or you can go to the actual tool and click line. Go from the corner, and SketchUp will snap to that new protractor point that we put in. Do it again on the other side, and you've got your cutter head. And that'll all be accurate to your actual router bit, and that'll be cool because your actual file will be exactly what you're making. So just finish off this rectangle. Let's say you're going to make, the next thing that you're going to want to do is figure out what panel thickness you're going to do, whether that's 1/2 inch panels for your walls, or 5/8 inch panels, whatever board thickness is that you're going to use for yours. So you're going to do 1/2 inch boards. Finish that rectangle. You can go ahead and delete the rest of these angles now. and you're left with this square, and I'll show you why that's important. Take this square, as I said, the lay jig uses 1 9/16. Yours may not use 1 9/16, but we'll just assume that we're sizing our boards appropriately with that. You could also be hand cutting these where you would take your compass and divide it with your compass, but we'll just assume that this is similar to my jig. But as I said, it can be anything. Take this object, paste it in, and essentially what we've done is created our first stage of our tails and pins as a 3D object. You can delete the rest of that stuff, you could keep it. So I'll show you what you can do with this. I use that to make all of these, and I'll show you my my resources. I have it organized so that I have all of the artwork that I'll ever need to redraw any of this stuff in case I need to do something a little bit different. Say I want to have a you know, a point in this where there's a channel to put a drawer bottom or something like that. I don't have to go and redraw all of this stuff as a model. And everything here is accurate to the actual size that we're going to make. But all you essentially need is this piece, is that original one, and then you can do as many in a row as you want. And I'll show you how I did that. Go back to our working file here. I could take this, 1 9/16 increment, or yours might be 2 inches or 3 inches or whatever size that you normally do between your tails. Now we've got something that we can use to create the tails and the pins board. So I'm going to go and I'm just going to rotate this quickly just so it's easier for us to follow along. I want to make this a group so I don't have to redraw this again because I hate redrawing stuff. I'll copy it, and let's make the pins board first. It's a little bit more straightforward. So you got your file, it's copied, it's a group. Let's go and explode this quickly. Take one of your pins, and we're going to push it up. You can see it's already starting to look like a pin board, right? Our boards are 1/2 inch. That's the thickness of our finished boards that we're going to be planing down or sizing. Whatever we're milling to is what we're making our pins push to. So I took the push-pull tool. It's P on the keyboard, or you can go to your actual tools bar and grab it, push it up. You could either follow along the points that you've already pushed, or you can go to anywhere and go to your measurement section and just write 1/2 inch. Same thing for the last one. We'll just snap it to the same place. So there you go, you've got pins. Make that a group. So you see at the bottom of it, we're missing some geometry here, right? Let's go and make a rectangle here. Explode this. Sorry, keep that rectangle. I usually like to make these, some amount of inches just so it's easier to see. It doesn't have to be anything in particular. Go and explode this. You can delete all these lines now. Now you've got a pretty good resource for a pins board. And I only do 1/2 of it. I don't do pins on both sides, and I'll show you why. Let's just move this over a little bit. We'll rotate it just so it's easier to see. So now you got your pins board here. Let's flip this around so we can reference it. You've got your pins board here. Here's your pins board. Your pins come out of the board. Now we have to make the tail board where the tails stick out and then a board comes through it. Honestly, everything on Sketchup is pretty easy to get a grip on. We're gonna go back to, guess what, the push-pull tool. Hey, you could draw these rectangles by hand. I barely draw out shapes by hand if I don't have to. Push it up, whatever our board thickness was. Remember, our board thickness was 1/2 inch, so we push it up 1/2 inch. But it could be 3/4 inch or 5/8, whatever you make your panels to. And that'll probably depend on whether you're doing, drawer boxes or, regular boxes, anything like that. So you've got your pins pushed out. Now, the last time we made a rectangle and we push it down to create our pins, this is going to be a little bit different. We're just going to take our rectangle tool, draw out some rectangles, because our pins go at the opposite orientation. So we want to make sure that it's going the correct orientation for what pins are. And once again, we can go and delete a lot of these lines. And you've got yourself a tail board and a pin board, or half of each rather. Now, when I did my, absolutely ridiculous resources section, I didn't go and make that over and over again all the way up. I just made the first one pin, and then I doubled it and I deleted lines. I didn't go and draw that whole file every time. Otherwise, this would have taken me forever to do that. But because for my jig it uses 1 9/16 inch increments, it worked really well for me. And yours might be similar, but in any case, we'll go back to our finished box. So now we've got these two pieces. What do we do with that? We got to build a box. We can delete these because we don't really need to make those exactly like that. So we'll take this, make a group. That's already a group. And we're going to orient this as if we're building one side of our box. So our box is standing up. These are going to be our pins, so we'll move it over. I'm just using the move tool, M on the keyboard, and the rotate tool, which is Q on the keyboard. So I'm not going to explain every tool that I use all the time. If you have any questions, feel free to message me. And we're missing some geometry here. What happened? Sometimes when SketchUp's missing geometry, you just have to go and redraw the lines because it's not going to guess the lines for you, but it's pretty straightforward. So we'll take this board and we'll rotate it again so that it's standing up. You can just press the arrow keys to go to the different rotate abilities. We want to rotate it along the green axis, 90 degrees. Stand that up. Now, if we've done our measurements correctly, these two will line up. If we haven't, they won't. So we've got one corner. You could have built each one of these specifically to whatever size you want, but I don't do that, and I'll show you why. I have these two pieces. Say I want to build a different size box. Say, normally I make a box and it's, 12 inches deep and it's, let's say, 24 inches long. But the next time I build a box, it's only going to be 6 inches deep. I'd have to redraw that entire panel, which is crazy. I'll make it bigger just so it works better on this video. But take these two parts, copy it, Command C to copy and Command V to paste it. We'll rotate it again. And you could flip those parts as well, but because our parts are identical, we can just rotate it. And we'll just snap it to the guide point. You'll see on your screen a little thing will say guide point. That's how you know you're in the right spot. And we've got one more side to do, so we'll take these 4 parts, copy it, turn our camera around. It's Command O to orbit, which is your camera movement on your viewing screen. It's O to hit that, and H brings up your hand to move things around. So Command V to paste it again, and we'll turn this 180 degrees. And we'll drag that onto our guide point. So we have our 4 corners. Once again, we're going to be lazy. We don't need to draw every part. So we'll delete some parts. What we do need is 2 of our pin boards, 2 of our tail boards. So this is the depth of the box. This is the length of the box. That's all we need. So we'll take this board. As always, we're going to get the push-pull tool. We're going to use this all the time. Move that right over. We can take these 2 parts and explode them. Delete some lines. Now we've got, let's make this a group. Make these a group. We can hide this. We can delete that guy because we don't need it anymore. Now we've got our pin board. It's the accurate length, 24 inches, what we need for our box. It's got pins on both sides in the right orientation. We've got our 1 pin board. We don't need to redraw that again. So let's go to our hidden geometry. We'll hide that. Turn hidden geometry back off. We'll do the same thing for our tails. I'll probably misspeak 100 times as we're doing this video and just call one thing the other. It's a pin board, tail board. I'll probably get it backwards a whole bunch of times. There you go. So we've got our 2 boards. Now go and make that a group again. You got them here. You can just paste them, copy them and paste them, flip them around, grab it from a point that is going to be on both sides, put it in position, and everything fits. You've got yourself a dovetail box. From here you could add a drawer bottom. You could cut it in half before we do this if you want. You could be a dovetail drawer. It could be a dovetail box. I'll show you quickly how I might make a drawer runner. Actually, let's unhide that quickly. If I'm going to put a drawer bottom in this, I'll probably do something like, let's just turn off the hidden geometry for a second. I'll probably do something like a 1/4 inch drawer bottom. And I'll want to cut it so that it doesn't interfere with where my pins and my tails are. So for us, that's 25/32. Let's pull that up there. That's going to be a 1/4 inch. I'm just guessing. I'm sure this is probably going to end up being the wrong location, but for this video, it'll be fine. We can take that, we can push it in however deep, we do it on our actual build. Make that a group and hide this. Turn the hidden geometry back off, and we can go and continue that cutout there. Go and hide this piece so we can just see as far as it actually goes in. There you go. Now you've got the channel in the actual boards, so you have it for your plan where you might actually put a drawer box or a drawer bottom. And you can do the same thing. You can take these two parts that you need, copy them and paste them. Now you have your location for your drawer bottom. Your drawer bottom is just going to be a rectangle that fits into that slot. You know, take that. You can press F for the Follow Me tool if you want to increase the size of it. And you can actually put in, you know, we did a 1/4 inch cutout. Say your cutout is different. Say it's 1/8 of an inch. You can make this distance whatever that distance is. We did a 1/4 inch, so it's pretty straightforward. We made our cutout a 1/4 inch tall, so we can do that when we push it up. 1/4 inch. And there's our drawer bottom. Group. So now we know exactly how big all of our box panels are going to be, including, make this a group, make this a group. Including the actual dimensions of our drawer bottom, which would have been pretty easy to figure out for this box because it's pretty even increments, and we just did 1/4 inch cutouts. But as we said, yours might be different. If yours were different, it would do all the math for you, and we'd know that that's 23.5 by 11.5, which is pretty cool. It's cool that Sketchup does the math for you, because whenever you can avoid doing the math yourself, that's good. And that's one of the reasons why I really like Sketchup. We've got all the sides of our panels here. We've got a box as much as you need a box. And you can go to our finished model here. You know, obviously for this one, we put some textures on it. I'm not going to go through textures in this video, but it's essentially the same thing. That's the same process that I did to make this box or any other box that I might make. And I don't have to go and make this from the beginning every time, because I have my resources file like this. It has 1/2 of my pin and tail board for every size that I'm going to make. So my pins board for 1 tail, 2 tail, 3 tail, 4 tail, whatever. Or if I know that my drawer has to be, you know, somewhere in around the 6-inch range, or it has to go under that, then I know what size to do, and I don't have to redraw that. I just take these two parts and build a box out of those, you know, and it's as easy as just taking the parts and rotating them, and that's it. And that's the easiest way that I found to make dovetail drawers. I would definitely suggest, if you're going to use SketchUp for making furniture, to make design resources, and specifically if you're going to do dovetails, make a dovetail resource file, and you could just copy and paste these and bring it into another file that you've already done, and you know, build your drawer in that file. It's super easy. So there's our finished box. I hope you liked the video, and you know, let me know if there's anything that you want to learn, and